Did you know that despite electric vehicles being the future, Tesla alone can only produce about 2 million cars per year? That's just a fraction of what traditional automakers churn out. But why does this matter right now? Because as demand for EVs skyrockets, the unseen challenges in mass production could mean long wait times and higher prices for you. The supply chain is a tangled web of rare earth minerals, battery shortages, and manufacturing bottlenecks. What's holding back the electric revolution? We're diving into the hidden hurdles that are keeping electric vehicles from flooding our roads. Stay tuned to uncover the surprising obstacles in this transition to greener transportation. The scarcity of lithium and cobalt is a critical bottleneck in electric vehicle production. These elements are essential for battery manufacturing, but their availability is limited. Consider that nearly 70% of global lithium reserves are found in just 4 countries: Chile, Australia, Argentina, and China. Similarly, the Democratic Republic of Congo holds about 60% of the world's cobalt reserves. This concentration creates vulnerabilities in supply chains, driving up costs and creating geopolitical tensions. Tesla has faced these challenges head-on, investing heavily in mining operations to secure its own supplies. As demand for electric vehicles skyrockets, securing a steady flow of these materials will be crucial. The next challenge we face is the environmental impact of extracting these minerals. Electric vehicle production relies on a complex web of suppliers for components like batteries, motors, and electronics. This intricate supply chain often leads to significant bottlenecks. For instance, the shortage of rare earth metals used in EV batteries has been a persistent issue. In 2021 alone, China controlled over 60% of global rare earth production, creating a dependency that can disrupt manufacturing if supplies are restricted. Take Tesla's Gigafactory in Nevada. It faced delays due to supply chain issues with battery components. These inefficiencies highlight the vulnerability of EV mass production. Addressing these challenges requires not only diversifying suppliers, but also improving logistics and inventory management. Understanding how these hidden hurdles affect production is crucial for moving forward, as we'll explore next with the impact of geopolitical tensions on global supply chains. Regulatory challenges are a significant hurdle for electric vehicle mass production. Consider how stringent regulations vary greatly across countries, making it difficult to standardize manufacturing processes globally. For instance, the European Union has strict emission standards that require advanced battery technology, while China focuses on fostering domestic innovation through subsidies and partnerships. These differing requirements mean automakers must adapt their vehicles to meet local regulations, adding complexity and cost to production. Take Tesla, for example. They had to build a gigafactory in China to comply with local laws requiring significant domestic investment. Navigating these regulatory mazes is crucial, but also incredibly time-consuming and resource-intensive. As we delve into the next challenge, it's clear that overcoming these hurdles requires not just technological innovation, but also strategic adaptability across diverse markets. The lack of charging infrastructure is a significant barrier to widespread electric vehicle adoption. In the United States alone, there are over 27 million registered vehicles, yet only around 40,000 public EV chargers available. This stark disparity means that many consumers are hesitant to switch from gas-powered cars due to range anxiety and concerns about finding a charging station. Consider Norway, where electric vehicles make up nearly 60% of new car sales. This high adoption rate is partly attributed to their extensive network of over 10,000 public chargers for just under 5 million people. This kind of infrastructure support is crucial. Without it, the dream of mass EV production remains out of reach. As we look at how policy and investment can bridge this gap, it's clear that charging stations need to become as ubiquitous as gas stations are today. Global events like pandemics and geopolitical tensions can severely disrupt supply chains for electric vehicles. Consider how the pandemic in 2020 led to a shortage of semiconductors, which are crucial components in EVs. This shortage caused production delays for many automakers worldwide. Take Tesla, for instance. They had to halt production at their Shanghai plant due to these shortages. Geopolitical tensions also play a significant role. The ongoing conflict between Russia and Ukraine has disrupted the supply of nickel, a key material used in lithium-ion batteries. These disruptions highlight how external factors can significantly impact EV mass production. As we delve deeper into the complexities of manufacturing electric vehicles, it becomes clear that a stable global environment is crucial for sustaining these efforts. The rapid progress in battery technology has been a game changer for electric vehicles. Tesla's Gigafactory, for instance, can produce 35 gigawatt-hours of batteries annually, significantly boosting production capacity. However, even with these advancements, scaling up to meet global demand remains a challenge. Consider the fact that as of 2021, only around 4% of new car sales globally were electric vehicles. This figure highlights how far we still need to go in terms of mass adoption and production. Manufacturing bottlenecks, such as limited access to raw materials like lithium and cobalt, further complicate the picture. These constraints can lead to significant delays and increased costs. Moving forward, addressing these technological limitations will be crucial for achieving widespread EV adoption. Achieving economies of scale is crucial for making electric vehicles financially viable. However, scaling up production without compromising quality remains a significant hurdle. Tesla has shown that mass-producing EVs can be done efficiently, but they still face challenges maintaining quality at their gigafactories. In 2021, Tesla produced over 936,000 vehicles, yet issues like battery defects and software glitches have surfaced repeatedly. These problems highlight the difficulty in balancing scale with precision. Consider the Volkswagen ID.4, which faced production delays due to complications in integrating new battery technologies at scale. Ensuring consistent quality across millions of units is no small feat, especially when dealing with complex electric components. As manufacturers push for higher output, the risk of quality issues looms large, threatening both consumer trust and financial stability. This challenge will continue to shape the future of EV production as companies strive for a delicate balance between volume and excellence. The environmental footprint of EV manufacturing is a growing concern. Consider this: producing an electric vehicle can generate up to 15% more emissions than making a conventional car. This is largely due to the energy-intensive process of mining and refining lithium, cobalt, and other critical minerals used in batteries. Take Tesla's Gigafactory in Nevada as an example. It consumes enormous amounts of electricity, much of which still comes from non-renewable sources. While EVs emit fewer greenhouse gases over their lifetime compared to traditional cars, the initial manufacturing phase is a significant hurdle. Addressing this issue will require more sustainable mining practices and increased reliance on renewable energy for production facilities. As we move forward, it's crucial to balance the benefits of electric vehicles with the environmental costs of their creation. Consumer perceptions significantly influence electric vehicle mass production. Consider how Tesla's early success transformed public perception, making EVs seem more viable and desirable. In fact, a survey by J.D. Power found that 40% of U.S. consumers now consider buying an electric car for their next purchase. This shift in consumer sentiment is crucial because it drives demand, which in turn encourages manufacturers to invest more in production capabilities. Market dynamics also play a pivotal role. Take China's aggressive push into EV manufacturing. They've become the world's largest market for electric vehicles, with over 1 million sold last year alone. Such market forces create a ripple effect globally, pushing other countries and companies to follow suit or risk falling behind. As we delve deeper, it becomes clear that understanding these dynamics is key to grasping how EVs are becoming more mainstream. The future of electric vehicles hinges on advancements in battery technology and supply chain management. Innovations like solid-state batteries could increase energy density by up to 70%, significantly boosting range and reducing charging times. Companies like Toyota are investing heavily in this area, aiming for mass production as early as 2025. Meanwhile, improvements in the supply chain will streamline the sourcing of critical minerals such as lithium and cobalt, crucial for battery production. Tesla's Gigafactory is a prime example of how vertical integration can reduce costs and ensure reliable supplies. As these technologies evolve, they'll not only address current challenges, but also pave the way for widespread EV adoption. With these innovations in mind, we can look forward to a future where electric vehicles are as commonplace as their gasoline counterparts. Strong collaboration between governments, industries, and academia is crucial for advancing electric vehicle production. Consider Germany's national hydrogen strategy, which aims to install 5 GW of electrolysis capacity by 2030 to support hydrogen fuel cell vehicles. This kind of coordinated effort can drive innovation and infrastructure development needed for mass EV adoption. Take the European Union's €1 trillion Green Deal investment as another example, focusing on sustainable technologies and reducing emissions. Such collaborative initiatives not only boost research and development, but also ensure a robust supply chain. Picture this. If governments incentivize renewable energy production, while industries invest in battery technology and academic institutions focus on efficiency improvements, we could see significant progress. This synergy is key to overcoming the hidden hurdles of electric vehicle mass production. As we move forward, let's explore how these collaborations can be scaled up globally. Despite the numerous challenges, the future of electric vehicles remains bright. Consider Tesla's Model 3, which has become one of the best-selling EVs globally, selling over 500,000 units in 2021 alone. This success story is a testament to the growing consumer demand and technological advancements in battery efficiency and charging infrastructure. Companies like CATL are pushing boundaries with new battery chemistries that promise longer ranges and faster charging times. Collaboration between automakers, tech companies, and governments is also crucial. Look at how Norway has become a leader in EV adoption, thanks to generous incentives and robust infrastructure. These efforts highlight the potential for widespread EV adoption. As we move forward, continued innovation and international cooperation will be key to overcoming current hurdles and ensuring a sustainable future for electric vehicles.